Hello, and welcome back to the Boombot series of videos here. And today we're going to take a look at the Rangefinder. This cute little eyeball looking thing up on the front is actually an HC-SRO4 ultrasonic rangefinder. And we have a transmitting speaker and a receiving microphone. Can't remember which side is which on there, but they send out pings of ultrasonic noise and time how long it takes to come back to the receiver. And because we know the speed of sound in air, we're able to calculate how far away the reflecting object is. It's actually a pretty amazing thing. Same technology that bats use for finding their insect prey, or that whales use for seeing underwater, whales and dolphins and all of the wonderful cetaceans that we seem to be trying to eliminate from the planet. Anyway, Boombot, Episode 3, the rangefinder featuring Seek and Avoid. What does your Boombot look like when it's trying to avoid an object? Here we go. The Boombot is set up and ready to go. It's not turned on just yet, but I've got my code on it. Now I'm going to turn on the logic power switch. There's no batteries turned on just yet. And this way you can go down underneath and you can observe the behavior of your signal LEDs to the L293D. So this is your motor controls on there. And as I put my hand down in front of that rangefinder, changing the range, you can see that the signals to my motor are going to change. So that gives me a sign that my motors are going to do something on here. Looks like they're moving forward right now, and when I put an object in front of it, it should back up and turn a little bit, and away it goes. So here we go. Let's give the motors some power, and we're off across my office floor and doing lovely wheelies as it comes to a stop and kicks itself and turns it around. And there we go. It's not running into anything. Now, it's not particularly intelligent in its algorithm. It's like an early series Roomba. It's just driving around on there and trying to make sure it doesn't hit anything. Right now, I've got the range set to 50 centimeters. You could set it to less or to more. You can jump in front of it. This would probably be good to put down on the ground and entertain your cat for a while. Anyway, here we go. This is about enough of all that. And so there you go. You can see what we're looking at from Object Seek and Avoid. Now, in order to do all of that, we needed to have the rangefinder hooked up to our Arduino. And if you take a look at the schematic, you can zoom in on this section of the schematic down right here, and you'll see that we're using pins A4 and A5. Now, A4 and A5 are actually pretty valuable pins to be devoting to a digital application because those are analog inputs, and we could be using them for reading an analog signal in there. And there's lots of things. We could put temperature sensors on there to read analog voltages, but I've specifically chosen A4 and A5 for the rangefinder because you can see I've also got these tied in to a few other headers on your board. And those other headers are on there for a later higher level project where what we're going to do is we're going to remove this ultrasonic rangefinder and replace it with a laser rangefinder or possibly multiple laser rangefinders. And the laser rangefinders, this is down the road, something that you can do later on as the project advances, use a form of communication called I²C. Okay, it's inter-chip communication, ICC, and of course when you multiply C times C you get a squared. So or no, integrated circuit is what it was called. So that was two I's and then a C. That's why it's I squared, not IC squared. We'll deal with it later, okay? But that's why you see when you take a look at these nets right down in here, okay, yes, they come down to 2 pins on our ultrasonic rangefinder, but they also come over and are used on a number of headers over here later on, so we can remove the ultrasonic rangefinder and replace it with a laser rangefinder, which can provide faster responses or multiple responses. And weirdly, the laser rangefinders cost about the same as the ultrasonic rangefinders. They're both relatively inexpensive, under $10. Amazing technology for what you're getting for the price. Okay, so we've got these 2 lines coming down here, and you'll notice that when they come down to the ultrasonic rangefinder, we've got 4 pins on our HC-SRO4. It's quite a nice little device right in here. And if you look at your HC-SRO4, you'll notice that the pins are labeled VCC, trigger, echo, and ground, and you should see those same pins showing up on your printed circuit board design. Okay, now I've covered how to use the HC-SRO4 in a previous video for our first year class, and it's available on my channel here. You'll find lots of information on the HC-SRO4 online. People have been using this with Arduinos for all sorts of creative things, and just happens to work out really well on our robot. And it does have two different lines right on here, the trigger pin and the echo pin. So let's take a look at how those pins actually work and send the signal back and forth. Okay, so this is a little logical diagram of what's going on with our pins. And you can see in here that the trigger pin just turns on for a really brief period of time. Okay, in fact, I've probably drawn that in there too long. We're just turning it on for a couple microseconds. And basically what that's doing is that's sending a signal down to the HC-SRO4. And if you look at the HC-SRO4, you'll notice that it's got a bunch of integrated circuits on it to begin with, okay, and even a little crystal on this side. So the HC-SRO4 is actually running its own microcontroller on board, and that microcontroller has software on it that it uses to calculate the distance measurements. It doesn't just send out one ping or one pulse. It's a reasonably sophisticated device. It sends out a number of pulses and times how long they each take to return, filters out some of the worst data, and gives you an average of what it sees on the remaining good data. So that's why we get reasonably nice measurements off of it. And to tell it to go out and do its thing, because it doesn't know when you want it to measure, you need to send it a signal on the trigger pin, and it goes high and it goes low, and that tells the chips on here that it's time to go and take a distance measurement. Now, once you've sent that trigger right in here, the sensor goes out and measures the range. So on board your HC-SRO4 right now, it's in here and it's going ping, and listening for the response, ping, and I think it does it something like 6 times in here where it goes out and it pings and it finds the distance and it tries to track that down to make sure that you've got the right distance. You don't really need to worry about that. That's all baked into the chip. If you look at the data sheet for the HC-SRO4, you'll find more information on what's actually going on inside here. It's a really neat little device. Anyways, once it's gone out there and done its thing and found out what the distance is, it needs a way to communicate that back to your Arduino. And it does that on what's called the echo pin. Now the echo pin is going to come in right here, and basically this board will set the echo pin high, and the longer it holds that pin high for, so the longer this high pulse lasts, then the further the distance away that your object is. So what you need to be able to do is you need to be able to measure the length of this pulse right here from the start to the end. And so if you haven't used it before, we're going to use something called the pulse in command on the Arduino, and that's going to measure that pulse length right in there on the echo pin. Okay, so now before we get on to our actual object avoid code, let's just take a look at how we would go about using this and double check to make sure that it works, because it's a lot more fun to make sure that you know that your sensor is working and then go to try to integrate it into something. Okay, so here's our Arduino code, and you'll notice my Arduino IDE looks, well, in 2021, it looks a little bit different from what you've been using before. I've upgraded to the new beta release of the Arduino 2.0 Integrated Development Environment, or IDE. It's a free download from the Arduino site, and it's got some features that I kind of like, but if it looks a little bit different from what you're used to, it's just the new version. Okay, things keep changing all the time. And anyway, it's got some benefits. It compiles faster, it uploads faster, does a whole bunch of nice little things. Now, oh yeah, look at that. When you put when you mouse over something, it pops up and tells you exactly what that type of thing is supposed to do with all the comments that I've included right on here. Really nice and useful stuff right on there. Okay, so anyway, Arduino IDE 2.0, worth checking out. Everything on here works fine with whatever version of the Arduino integrated development environment you're using. Okay, so basically I've taken the code that we had in our last lesson where we were doing a pre-programmed drive routine, and I've come down here to our void loop, and I just removed all of the drive, and I put a serial print in here, and I just said I want you to print what the range is, and then I run a rangefinder function. I'm going to talk about the rangefinder function in a minute, and then we'll just print out a carriage return with a println and centimeters to say how far it is. You'll see that operate in just a moment here. Before we do that, there's a couple of things that I do have to point out that I did add to the code in places other than void loop right in here. Okay, now obviously if I'm going to refer to a pin as trigger, okay, then I've got to have a trigger pin on here, and probably a good idea that I add a comment on here that this is the trigger pin for the HC-SRO4 ultrasonic rangefinder, and this is the echo pin for the rangefinder. A long pulse means a long distance. Okay, and we can actually do a little bit of math to break that down and make sure that our distances are measuring correctly. And since I've defined these pins now, I also in the code during our setup, I have to set pin modes in here. And so I've added pin mode trigger comma output. If you don't put that command in there, then when you go to set your trigger pin, it's not going to trigger and you're always going to get wonky results. Okay, now your Arduino doesn't know what rangefinder means unless you tell it. Okay, and so just like with our drive routine, it made sense to create our own function to get a whole bunch of the code that we're going to use repeatedly out of the main loop and put it somewhere where we can look at it and work on it independently. Okay, so now I've got my drive routine in here. This is all worked out and tested, and we proved that in the last video in the sequence in the last lesson. And now I've got a routine down here called the rangefinder. Now this one's a little different where my drive routine was void drive because it didn't return a value. This routine is going to return an integer value, and that integer value is going to be a number telling me how many centimeters it is to the nearest object. So instead of saying void at the beginning, I say int, and that tells the Arduino to expect this to return an integer number. And you'll see that the last thing that we do before this function finishes is we give it a return command, and we're going to return range. Now, the other thing you'll notice that's a little bit different is that we just went bracket, bracket right in here. Okay, there was nothing being passed to this. We didn't have to tell it how fast we wanted motors to go or anything like that. Rangefinder just goes out and does this one thing, and we know where all the pins are. We don't need to pass variables to this function. So slightly different setup, and compare that setup to what we had for our drive routine right up here. Void drive, okay, we're not returning a value from the function, but we are passing two values into the function. Down here, okay, we are returning an integer, but we're not passing values into it. And of course, that declaration for the function includes all the statements between the opening ellipses, or squiggly bracket if you prefer, and the closing ellipses. All right, now there are a few things that we are going to do. One of the things is that we're going to use this command called pulse in. And when I mouse over top of it, you can see that the new Arduino IDE pops up with information, so I don't have to go into the help file to find out more about the pulse in command. And it tells me what it's going to return. So it works with an unsigned long variable type, which is what we typically use for time, okay, because those time numbers, when you measure them in milliseconds, can get really big. And down here, it uint8t. That basically means an unsigned integer, but an 8-bit integer. So anyway, that's just a short way of saying it's looking for an integer variable. And although Arduino claims to have made things easier for people to understand, they still have some of these geeky engineering descriptions built into it. Okay, so anyway, and then we've got unsigned long timeout, which is a maximum number in there. So basically, if you take a look at that and scroll down here, it's even got examples of it built in right here, and it tells you what it does. And so the pulse in command measures the length in microseconds of a pulse on a pin. Now, you can say whether you want to measure a high pulse or a low pulse. Okay, so because sometimes the signal will be high and then it'll dip low and you want to time how long it's low. Sometimes you want to, it'll be low and jump high and you want to measure how long it's high. Okay, gives you some range of how long the pulses can be. And you have to call it at least a few dozen microseconds before the start of the pulse, it says. Usually that's not a big problem for us. And then more complex information about the no interrupt concept, but basically then it gives you an example right in here. So let's take a look at how we're going to use it in our example. Now, the first thing I've got in here is you saw it referred to as in the description of the command as a timeout. Now, when you hand control over to the pulse in command, it will go in there and it will wait until it sees a pulse. We call this a blocking function. It's kind of like delay in that nothing else happens while it's waiting to see that pulse, just like nothing else happens when you're in the middle of a delay statement. And that's fine because it's busy, it's listening for that pulse to come in. But sometimes, there's something wrong with the circuitry. Sometimes it's a really long distance. Sometimes that pulse just doesn't come in. So what a timeout does is it says, go and listen for this command, and if you don't hear it, and in this case, I said 17,400 microseconds, okay? If you don't hear it, then something's too far away. Now, this limits the largest range that we can see to 300 centimeters, because if the pulse length gets too long, we'll hit the timeout before we end up measuring the entire length of the pulse. But keep in mind, although 17,400 looks like a big number, we're measuring in microseconds and they're really small. This is like 17.4 milliseconds or 0.0174 of a second. Okay, so pretty quick. Still, when you're doing it multiple times, that sucks up time out of your program, and you could probably take this down to a smaller number because quite often you don't need to measure more than 300 centimeters distance. Okay, so we've set what our timeout's going to be, and then we come in here and we do a digital write pin, and we set that trigger pin, okay, which we've already defined as either A4 or A5, I can't quite remember. Oh, put my mouse over top of that. There we go. And actually it says the value is 19, which is the actual number for A5. It goes through a couple of translations in there to get from A5 to pin 19. So trigger write, we set it high. We wait 2 microseconds. That's it. Bang. Really, really quick. We just need a tiny little signal to come in there. And then we set the trigger pin low. And now we create a variable called range, okay? And we say that it's going to be the pulse in. Okay, maybe some of the features of the new IDE are a bit of a pain when trying to explain your code, but it's going to be the pulse in. It's going to measure it on the echo pin. It's looking for a high signal. Make sure you capitalize high. And it's going to break out of the function if it hits the timeout, okay? Now, it's going to get us a number in microseconds, and if you divide that number in microseconds by 58, that gives us the distance in centimeters. Why 58? I guess it takes 58 microseconds for sound to cover a centimeter or something like that. Okay, anyway, 58 works out pretty close. Now we do have something in here where I say if the range is exactly equal to 0, then the range is going to be equal to our timeout times 58, because if you time out in this sequence, so if you go in to measure the pulse and either there is no pulse returned or the pulse is too long and you're not able to get the answer back in time, then you're basically looking at something way off in the distance, not something 0 centimeters in front of you. And so this will return the 300 centimeter distance. This command right here passes it back into our routine. So there's our rangefinder routine. It's actually pretty simple. It goes out, it triggers the trigger pin, it measures the length that comes back on the echo pin, it divides that number by 58 and returns a distance in centimeters. So now back in our void loop routine, what we're going to do is we're just going to test that by doing a serial print of range. And then we call the rangefinder function in here. That gives us a number, and that'll print that number out. It'll print it in centimeters. So I'm just going to plug the HC-SRO4 back into my little Boombot right here. Plug the Boombot into my serial port. And there it's going through its boot up routine. And now the serial monitor on here. Tools, serial monitor. It's kind of neat. The serial monitor actually appears on the same screen. And now it's measuring some distances. And it's jumping back and forth from 34 to 200 centimeters. Let me put my hand in front of it. And yeah, it was just having trouble finding a target out there. 4 centimeters, 3 centimeters, 2 centimeters. You can see my hand coming in closer and closer, and the distance getting shorter and shorter. And if I pull my hand away, then it runs out, and we're measuring some really long distances out there. And it's just kicking in at different time periods right on there, because I forgot to put a delay statement in there, and the serial print statements are backing up over top of each other. But basically check that out and make sure that your rangefinder is working reasonably well. Okay, now once you've got the rangefinder working reasonably well, I'm just going to turn the serial monitor off right here. We want to start making an algorithm so that our robot can use that rangefinder function to go out and avoid things. And this is where it's good to have a plan. Before you go in and start writing code, you should be sitting down with a piece of paper and laying things out logically and drawing them out of your head and saying, well, what sequence of things do I want to do? If you can't express your program in English, or pseudocode as we like to call it, some way so that human beings can understand it, you have no chance of having the robot understand what you want it to do. Okay, you need to be able to break things down into small, orderly steps. So for an object avoid routine, I'm going to start out with my robot in the default position of driving forward. Okay, you'll recall that from the video. The robot starts out driving forward. Then we're going to do a range check. Okay, and now we're going to say is the object less than however many centimeters away. Now in my code, I used 50 centimeters for X. You could try 30 so you could get closer. You could go right down to 10 if you wanted. If you make it too short, remember the rangefinder is sitting right here and the nose of the robot's right out over here somewhere. So if you make it too short, you're going to start smashing into things. But anyway, come up with an optimal number for X. We don't know what that's going to be yet. I used 50. Okay. Now, there's two answers to this question. Is the object less than X centimeters away? Well, if it's not, then there's nothing in your way. Carry on driving forward. But if it is, then you need to do something about it. Now, later on, when you've got the cannon mounted on your robot and the DF Player Mini, you could have the robot stop and you could have it say, "Get out of my way or I'll be trouble." And then you can have it start firing the cannon at whatever's in its way. Now, that's a nice little upgrade on there. But what we're going to do is we don't have cannons, we don't have sound. We're just going to back up and scurry away. So now we're going to back up. Okay, we know how to back up. Drive, reverse, reverse. You don't always have to back up. Sometimes you just want to turn. And then we're going to turn. I said 90. It doesn't have to be 90. You just want to make a turn so that you're looking in a new direction. Okay, once you've done that, you're going to come back either into here or into here, and you're going to keep repeating this loop over and over and over again. Okay, let's take a look at how that might look in code. Okay, so yeah, we're recording again. So here we go. We've got our loop in here. We've tested our rangefinder. There's no problem leaving that test code in here for right now. Now, why not? It's not hurting anything. Let's come in here and let's start out by saying, well, we want to drive forward. Now, this is where the beauty of having our subroutines built in, our functions built in. All I need to do is drive, and look at that, it's popping up the options that I want, and I want to go forward, forward. Now, you don't have to always drive forward at full speed. You could say drive 200, 200 to drive at a little lower speed, if that's what you want. Okay, now we're going to do a scan to check the range. Well, what we want to say is if, okay, rangefinder. So we go out and we run the rangefinder function. Remember, you need to put the brackets after it, even though we're not passing variables. It's just like confirming that you're not passing a variable to it. Okay, if the rangefinder is greater than 50 centimeters, okay, so what do I want it to do if it's greater than 50 centimeters? I put it into the brackets right here, and actually that's where I want the drive forward forward command, because I only want it to drive forward if the range is greater than 50. Let's just put that right in here. Drive forward, comma, forward. Okay, so that follows our code down here. We drive forward, we check the range. If the object is greater than X centimeters away, now I asked less and said no. In my code I said greater than and yes. Comes back up here, it drives forward, forward. Now if it's not greater than 50, we can just put in an else statement. Okay, what do we want it to do now? We want it to drive. Okay, reverse, comma, reverse. Okay, and then we want it to have a brief delay. I had about 300 milliseconds in there right there, just enough to back it up a bit. And then drive forward, comma, reverse. Turn a bit of a corner by setting the two motors to different speeds. And I think I delayed for 200 milliseconds in there somewhere. So just a quick back up and turn. And now that'll run right in there. Let's run the auto format command over the top of that, make it look all nice and neat and tidy. Why did this one not indent? That one should be indented right there. Okay, it's still beta version of the software. And so that code right there looks like it should be working out okay. Make sure that all your squiggly brackets, your ellipses line up with each other so that this one matches that one, this one matches that one. And let's pop that onto our Arduino right here, and we'll just do a quick upload. Compilation complete, upload complete. As you can see, it's really fast. Now I can take a look at the front of my robot right down here, and you can see that the red lights are on, the two outside ones. On mine, that's a sign that it should be moving forward. And just using the logic, you can see that when I pass my hand down in front of here, it goes into that routine where it starts backing up. You can see both sides go blue, and then one side goes red to make it go forward, so that we've got a little back up and forward on there, and the robot should be able to go out there and drive around. Alrighty, so that is how you make your robot do an object avoid routine, and you can put it down on the floor and drive your cat crazy because there's this strange thing scurrying around at unusual patterns. You can change the 50 on here. Okay, this is the distance that you're looking at. Put something in there different. You can slow it down a little bit by using 200, 200 in your drive routine. And you can see in here the real advantage we get from having functions to handle all of the commands for the robot. Okay, we offload all that into a different part of the code, and once we've written it, we don't have to worry about it again. Now, your challenge is to take all of this logic and turn it around and get this working, get this tested on your robot, record a video of it working, okay? And then come in here and think about how you would change this logic in here to have it do object seek. Okay, so that your robot can go out there and find something. Okay, so now maybe your range of vision is a little bit longer and you're looking off in the distance, and as soon as you see something, you want to go out and grab it. So you're going to have to start out turning around, looking, and then you're going to say, I see something, and then I'm going to come at it. Oops, I lost it. And then maybe you turn the other way if you want. Keep turning the same way, whatever, until you can find it again and go out and chase something down. And with one narrow sensor like that, that's about the best you can do for object seeking. Make your robot go out, avoid objects using this code, get the video, then come back and change this code up so that you can have your robot go out there and seek objects, get that video, upload both videos. Now, keep them short, okay? Upload them onto D2L to show me your robot doing what it's doing. If you're just doing this at home and you're not part of my class, do whatever you want. But for my students, put that up online onto the page so that I can see that you've got both object seeking and object avoiding. Now, if you do want to add a little something extra to impress me, remember you've got buttons down at the side of the robot, okay? And you should be able to set it up so that when the robot boots up, it doesn't do anything until you press one of the buttons. And if you press one of the buttons, you should be able to press a seek button and have the robot go out in there and do seek. And if you press a different button, you should be able to have it go out there and do the avoid functions. Maybe you can even set it so that you can press one of these buttons to have it stop doing everything and just sit there for a while, because otherwise you're going to be chasing your robot down a lot with this code. Alrighty, object seek and avoid, 2 videos to upload, and if you really want to do something neat, try and get those buttons involved so you can control what mode your robot's going to be in. You're going to have to add a couple extra if statements, maybe a variable to remember which mode that your robot's in, and if you're looking for, well, I'll let you figure it out from there. Have some fun with it.